prove that this is question 4. The sum of the squares of two consecutive odd integers is an even number. So the keywords here are the sum, which means addition, squares of two consecutive odd integers. So let's start with let the first odd integer be equal to 2n plus 1. As you know, definition of odd is always 2n plus 1, and even is 2n. So that's the first odd. The next odd will be, well, we could say if the first odd is 2n plus 1, followed by adding 1 to that, we get the even, 2n plus 2, and then the next odd number will be 2n plus 3. So the next odd number, so I put here next odd integer will be 2n plus 3. So now if we sum of squares, so that meant that we will get a square of each one, if each of those, and we sum them together. So that will become 2n plus 1 squared plus 2n plus 3 squared. So what do we do here? We need to learn to expand this sum. I know if I'm expanding a plus b squared, that will give me a squared plus 2ab plus b squared. So in this case, the first one, a is 2n and b is 1. So I would get I'll get 2n squared plus 2 into bracket 2n times 1, because b is 1. So what I meant is that a is 2n and b is 1. And then I will get b cubed, which is 1 cubed, which is 1. So those, when I expand them, they become that. Now I've got a plus next, which is that plus, and I'm going to expand 2n plus 3, where a is 2n and b is 3. Again, so I'm going to do 2n squared plus 2 into bracket 2n times 3, because b is 3, plus b cubed, b squared, and b is 3 now, so it'll be 3 squared. This is 1 squared here, that's why it's 1. And so when I expand this, I'll get 2 to the power 2 is 4, so I get 4n squared plus 2 times 2n is 4n plus 1 plus 4n squared plus, now 2 times 2 is 4, 4 times 3 is 12, 12n plus 3 squared is 9. Now what do I do next here? I would have to collect all the like terms. So 8n squared, so that's that plus that, plus 4n plus 4n plus 12n is 16n, and then plus 1 plus 9 is 10. At this point, I would have noticed that 2 is a common factor here. Taking 2 out, I will get 4n squared plus 8n plus 5. And then what I need to do here is to say, well, let 4n squared plus 8n plus 5 equals p, where p is an integer, and therefore I will get 2p, and then 2p is an odd, not a definite number from the definition of even and odd. So 2p is odd, and therefore we have just proved that the sum of the squares of 2 consecutive odd number integers is an even number. Now question 5. We need to prove that the raising of an even number to an odd power will give an even number. So the best way to start this is to say, well, we know that even number can be written as 2n, and odd number to be 2k plus 1, where, so I'm going to write that here, where n and k are integers. So, and then I need to write down 2n is being raised to 2k plus 1. So what that meant is I would have, well, 2n times 2n times 2n times 2n, and that meant that what I have is 2k plus 1 lots of 2n multiplied together. So in that case, I would then say, well, I will get, if I take out 2, because 2 is a common factor there, so if I take out 2, I would get n times 2n times 2n times dot 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 times 2n, and then I would say, well, I could say, well, let the brackets numbers be p, where p is an integer, so we have to write that down, so write it down here. So where p is an integer, therefore I will get 2p, and 2p is an even number. Question 6. We need to prove that the difference between any two rational number is also a rational number? Well, we know a rational number is a number that can be written as a fraction. So that's what a rational number is. So we got two rational numbers. So we can call the first rational number A, which equals to n over m. And we can call the second rational number B, which is k over L. So these are the two rational numbers. And the word difference means minus, difference means take away. So what we're going to have is the difference, which is A minus B, which can be n over m minus k over L. And in this case, they have a common denominator that we're going to write up. So the common denominator should be ml. So it's a multiple of the two. And therefore, I would have nl minus, well, how many L in ml? That's m. M times k will be mk. How many m in ml is going to be L? L times n is ml. And that's how I got those. And so, in this case, I could say that let nl minus mk be equal to p, where in this case now, so I've got to state that where A, B, N, M, L, K, and P are integers. So, but also since ML is an integer, we could then say, I can also say let ML equals R. So I would have to put KR here. So that's an R as part of the integer. So then I would then say P over R is A minus B, which is also a fraction. So, which is also a rational number, because a fraction is a rational number. Provided that R and ML and M and L are not equal to 0.